We are now on problem set number 3, spreading the news problem. You arrive at the school and meet your mathematics teacher, who tells you today's test has been cancelled. You and your friends spread the good news. The table shows the number of students Y who have heard the news after X minutes have passed since you and your friend heard the news. So this is the table. This is the table. Okay, so that failed. So let me just introduce you to the table. Okay, your X is from 0 to 40 minutes, and the Y who heard your news, your good news, is from 2 to 90 students. So for 0 minutes, of course you're the first two ones, you and your friend. So there are 2 students. After 10 minutes, 5 heard the news, and then after 40 minutes, there are already 90 students who heard about the news. Letter A, plot the points. Imagine a function fit to the model. Is the graph of this function concave up or concave down or both? Now let us graph the points. So what are those points again? Okay, let me have these points. So from 0 to 40 minutes. Well, I think 40 minutes is too long. So 0 to 40 minutes. Okay, I'm creating my table so I won't be lost. You could do the same. Okay, so we have X here and Y on the other part. So let me say this is my Y. So from 0, 10, 20, 30, 40. So an increment of 10 minutes. And at the beginning, there are 2 students. And then it became 5. And then it became 13:35. And then at last, after 40 minutes, 90 students heard the news. So we're going to plot this point. Therefore, we are going to need the axis. Okay. So let me say this is my x-axis and this is my y-axis. And my y is, let me take this on scales of 10. So 10, 20, 30, 40 onwards. And this is in terms of 5. So 5, 10, 15, 20, 25, 30. Okay. Okay, and this is my origin, of course. So the table shows that at x is equal to 0, the students who heard the news is 10. So it's probably here. And after 10 minutes, there are 5 students. So it's half of the 10. And then after 20 minutes, 13 heard the news. So it's somewhere here. Then after it's 20 minutes. Okay, so 20 minutes, ma'am. This is here. Okay, and after 30 minutes, this is 35 students. So let me have it here. 35 students. Okay, so from this graph, I will leave the other x and y values because this will seem to be this graph is more than accurate to depict the picture. So I'm going to graph now the relationship between the x and y values. It seems like this. This is my function, okay? So this function, my letter B is, or did we answer all of the questions for A? Is the graph of this function concave up or concave down or both? You could see that this is concave up, right? So this function is concave up only, no concave down. Okay, at this point, okay, at this domain, because we don't have a restraint yet, but in reality, all of your class has a certain population restraint, so this will be also restrained to a leveling off, and it will come to an asymptote. So there are 1,220 students in this school. Use the numbers of students at 40 minutes or at 0 minutes and 40 minutes to find the equation of the logistic function that meets these constraints. So in here we are going to get the graph, or the equation, I mean. Okay, so we are considering the first point and the last point. So our first point is 0 and 2. And the last point is 40 and 90, where the first coordinates are in terms of minutes and the second coordinates y are in terms of the students who heard the news. So we are going to get the equation. Okay. So what is the general equation of a logistic function? The general equation is f of x is equal to c over 1 plus ab raised to negative x. And what is our c? Our c is 1,220. That's the restraint. So when my y is 2, so this becomes 2, is equal to c is 1,220 over 1 plus my a is unknown, my b is also unknown, my x is 0. That's my first equation. My second equation is when my y is 90. So when my y is 90, that's 1220 over 1 plus my a is unknown, my b is unknown, and my y is 40, or my x is 40 rather. So this is my second equation. Next, this would be 2 plus 2a, because b raised to negative 0 is just 1. So that makes it, and then multiplying it here, this becomes 2 plus 2a. This is equal to 1220. And in here, this will be 90 plus 90a b negative 40 is equal to 1220. Therefore, my a here is equal to, computing for a here, that's 1220 minus 2, that's 1218. So 1218 divided by 2 gives me 609. Okay, so I will replace the 609 to the equation here. So my a is 609, therefore I will have 90 so this is 90 plus 90 times my a is 609, b negative 40 is equal to 1220, and that means that my 90 times 609 b negative 40 is equal to 1220 minus 90. So that will give us 1130. And dividing both sides by 90 and 609 will give us 90 times 609. So that will give us so we can just cancel this, and our b negative 40 is equal to 1130 divided by 90 divided by 609. So that's 0.2, oh, okay, 0.0206. Okay, and 1 over 0.0206 will be B40, right? And 1 divided by 0.0206 equals 48.5437 B40. So therefore my B is equal to, so we just square root our answer, or 40th root of our answer, so 48.5437 raised to the root, 40 root, so 40 root of 40th root of 48.5437 will give us 1.019. So these are the things that we need. Okay, so we could now rewrite our equation. So our equation is actually f of x is equal to the logistic function 1220 over 1 plus our a is 609, and then our b is 1.019 raised to negative x. So this is our equation. So this is letter B. Okay? So this is letter B. Letter C. Plot the graph of the logistic function for the first 3 hours. So if you want to create a table for the first 3 hours, you can do so. But for now, I'm going to sketch the graph for the first 3 hours. So our standard function for this problem is y is equal to 1220 over 1 plus 609 times 1.1019. Is that correct? 1.1019. Okay, this is 1019. 1019. Okay. Raised to negative x. So this function actually has a graph. Well, for the first 3 hours, 60, 120, and 180. And these are the values. So this is the y-axis, this is our x-axis. So this is 400, 800, and 1200. Okay, so our ceiling, our upper bound, our asymptote is somewhere here, 1220. So it's here. Okay, so therefore, our function, the graph of the function will be something like this. Okay, if you want to check it, you can check, confirm, you can use this equation or you can use the table of values. So that's for letter C. Now we go to letter D. Based on the logistic model, how many students have heard the news at 9 o'clock a.m.? If you heard it at 8 o'clock a.m., how long will it be until all but 10 students have heard the news? Meaning there are only 1, 2, 1, 0. So let us solve that in the next slide. So let's do it here. So we begin with the function itself. And as long as we knew the function, we will not be lost. So y is equal to 1220 over 1 plus 609 times 1.1019 raised to negative x. And this will give us 1220. But let us substitute now our value for y. So our y is equal to 60. Based on the computations, the tables, okay? So our y is equal to 60. If you have problems for the 60, you can solve it. Or, okay, wait. This is